Welcome back to Discovering Geometry with Mrs. Berry. This is Lesson 47. Today we're talking more about tessellations. We're going to be talking about tessellating non-regular polygons and how to make art with tessellations. Remember that tessellations are repeating patterns. Tessellations are repeating patterns that cover an area without gap or overlap. So we had talked about regular polygons and which ones we can tessellate. And remember, those were triangles, squares, and hexagons. But what about non-regular polygons? Could we tessellate a non-equilateral triangle? If you made a scalene triangle, could you arrange it in a tessellation? You could try this out by drawing a scalene triangle and cutting it out a few times. Remember that for a tessellation to work, we would need vertices to meet up and add to 360 degrees. Well, since the corners of three corners of any triangle would add up to 180, then I think we can add them to 360 as well. Here's a picture of a scalene triangle tessellated. You can see that at every corner, or at certain corners, we have enough triangles to tessellate. So does it work? Yes. Is a certain type of triangle needed? No. We can tessellate with an equilateral and a scalene, then I think that we could tessellate with an isosceles triangle as well. So our tessellating triangles conjecture is that any triangle will create a monohedral tessellation. Any triangle will work. What about tessellating with quadrilaterals? We know that a square tessellates. But would quadrilaterals that aren't squares tessellate? We can model this by cutting the same quadrilateral 8 to 12 times and then trying to put them together in a tessellation. Here's a few pictures. This is not even a parallelogram, it's not a rectangle, just a quadrilateral. But if we rotate 180 degrees, we can put it together and then turn it again. This one also looks a bit like a trapezoid, and this one. So we can see that any quadrilateral will create a monohedral tessellation, just like any triangle. Pentagons. A regular pentagon did not tessellate, but could you make a pentagon that does? Turns out that you can. Here's two different pictures of tessellated pentagons. We can create a lot of artwork with tessellations. Tessellations can be used to create designs with translations. You can use a regular polygon that already tessellates, such as a square or a hexagon. This artwork was created by M.C. Escher. Do you see the Pegasus? There's red ones and yellow ones, and they're all tessellated. There's no overlap and there's no gap between each Pegasus horse. So here's how this one was done. It was made with translations. The first step was to draw a curve at the bottom of the rectangle. Of the square. And then to translate that curve to the top of the square. So now you have opposite sides that have the same curve drawn, but just translated across the square. Then draw a design on the left side and translate it over to the right side. You can try doing this yourself as well. Take a square or a hexagon and do the opposite sides with the same curve and translate it up. Tessellations can also be made with a rotation. When we make them with a rotation pattern, the figures can face different directions. So in the last one, our horses were all facing the same direction. But when we use rotation, the faces will be in different directions. Here's a lizard artwork made with rotation. You can see that those faces are turning all different directions. So here's how this one was done. In the first step, a curve was drawn across the SI side, and then that curve was rotated across the IX side. A different curve was then drawn up between the G and the X, and that same curve was rotated to the G and O side. A third curve was drawn between O and N and rotated between the S and N side. So with this hexagon, 3 different curves were drawn and they were rotated to the side next to them. Another method of rotation would be to use an equilateral triangle for a design. 2 sides of the triangle will have the same curve rotated about the common point. The third side is a curve with point symmetry. So take a look at this one. We have this side rotated to this side, and then this third side is rotated in the middle of it. So it has point symmetry. You can turn this side to be symmetrical. You can do different designs. Here we have this side rotated to this side, and then this last one is rotated about the middle of the side. This one might be easier to see because the third side has no significant curve, just a straight line, but you can see how the first 2 sides have a curve that was rotated. Lastly, we can look at tessellations that use glide reflections. In these tessellations, the design will face forward and backwards, but it will not be turned in all different directions. Can you see this rider on a horse that was created? There's darker ones and lighter ones underneath. This could have been done with a triangle. So the first step was to draw a curve on just one side of the triangle. Then that same design was glide reflected down to the second part of that side of the triangle. We then have another curve drawn across the top, and that was then glide reflected across the last side of the triangle. So you can even see in this step 3, at first it looks like hands, but you could also see the feet that are going to be in the bottom when it's glide reflected. You could also use squares or parallelograms for glide reflection translations. Here's another step. If you were to use a 4-sided figure, you would draw a curve at the bottom, glide reflect it to the top, then you would draw a second curve on one side and only glide it to the last side. So now that you've learned about all of these tessellations, what can you create? Take some time to use one of these tessellation ideas to create some artwork. Here's one that I did. This one was just a translation tessellation.